In this video, we'll be solving this math problem under Algebra 2 involving functions, domain, and answers in interval notation with nested square roots here. So here's the problem statement. Find the domain of f of x equals square root of x minus square root of x plus 2, and write your answer in interval notation. So, for this problem, we have a square root inside another square root here. We have square root of x plus 2. So this means to find the domain of this function, we have to take into account the restrictions on both function or both square root layers. So as a quick review, the domain of any function is the set of all possible values it can possibly input so that the function is defined over the real numbers. So for this function we assume, and for most functions, we assume that it can only input and output real numbers. So that means no negative square roots or imaginary numbers. So the domain is the set of all valid inputs to the function. Okay, so to find the domain of this function, we have to work from the inside out, dealing with this inner square root first, because that's going to tell us what the restrictions on the outer square root are going to be. So we know that we cannot have any negative square roots in here for this function, so that tells us that x must be greater than or equal to negative 2 to satisfy the inner square root. Because if you had anything else, like a lower value, like negative 5, he would have negative 5 plus 2, which is negative 3, and that's a negative number and would result in a complex or imaginary number, which we can't have for this real function. So we must have x is greater than or equal to negative 2 for this inner square root. So like negative 2 plus 2 would be 0, which you can have a 0 square root that is defined here. So then we move to the outer root here, and we know we have one restriction already on x. We also know that x has to be greater than or equal to the square root of x plus 2, this inner part here. Otherwise, we're going to get a negative value for the entire inner portion of this square root here. So from there, we can say x must be greater than or equal to the square root of x plus 2. So yeah, this x here and the inner part, this must be greater than this inner part over here. And that tells us that x cannot be negative, which means x is clearly greater than or equal to 0. So x must be greater than or equal to 0, because if it was negative, say negative 1, you would have negative 1 minus negative 1 plus 2 under the square root. That inner one would then resolve to a square root of 1, but then you'd have negative 1 minus 1 equals negative 2, and then you'd be taking the root of negative 2 in the whole thing, which again is not allowed here. So it must be, x must be positive in this case, or non-negative, I should say. So from here, we have a pretty narrowed down restriction on x. We know that it must be greater than or equal to 0. So let's go ahead and do some final checks to make sure that there are really no other restrictions we need to take into account here. So at this point, we can just see what's the minimum value of x, such that we get a value of 0 under the largest square root, because that's going to tell us the greatest value of x for which this function is defined, or the lowest, depending on the bounds we set here. So we can try going to 1. If x equals 1, then we would have 1 out here. Actually, let's use a different color for this. So for outside, the value of x would be 1, then minus 1 plus 2, that would be the square root of 3, which we can just approximate here. We can say maybe it's around 1.7 or 1.8. But that's going to be greater than 1, which means we're still going to have likely a negative value here for this square root, which means we cannot have a value of 1 for x either. So that narrows things down even further. We keep going. See, x equals 2. In that case, we would have 2 minus 2 plus 2 under here, which is going to be 4, or the square root of 4. Then we have 2 minus 2, 2 minus 2 for the outer square root, which of course is the square root of 0. And as we said earlier, you can indeed have a defined square root of 0, so we have found the lowest successful or valid input to this function here. So x equals 2 is going to be our lower bounds in this case. Then anything above that is going to be satisfying the function. You can go on even, you can test x equals 3, x equals 4, and you'll find that they keep increasing this value here under the square root. So they ask for the answer in interval notation here. So if we want to represent all values of x, including 2, and going all the way up to infinity, we would write square bracket 2, comma, positive infinity, my best attempt at drawing the infinity icon, and then rounded parenthesis there. So it's going to be square bracket 2, comma, positive infinity, and we always use a curved bracket or parenthesis for the infinity because technically infinity is not actually a number. And there we have it. We have successfully solved this functions problem involving domains and nested square roots.